PASW equals SPSS. So I'm going to go to the Start menu. I'm going to go to All Programs. I'm going to go to SPSS, and then I'm going to go to PASW Statistics 17. Now I'll have a handout for you. Could you all see that, what I just did? Pretty straightforward? Okay, and then I'm going to go, this is version 17. Okay. And it takes a while to load up. It's kind of a memory hog. It takes a lot of memory to do it. And the first thing I want to show you is when it gets up there. Okay, the first thing, it'll open to a window like this kind of window, which is sort of, it tells you what would you like to do. Well, if you've already run some data, if you already have a data file in there, it's going to be listed right here in this box. Okay? And then you just have to click on that, and it'll run your existing data. Okay? It'll run the saved data file. If you're not going to do that, you're just going to cancel this. And I think, if you look up in there, see the question box? Can you see what it says? What's it say?
Run the tutorial.
Run the tutorial. All right? Now, the tutorials on this are real good. They seem very user-friendly to me, and I think that using them will be helpful to you. So if we go in there, let's just look at the kind of tutorials they might have. So if I go in here, I'm going to click the Run the Tutorial, and I'm going to say OK. And it gives me a menu of tutorials. So reading data, entering the data editor, all of these different things. So let's just go to the introduction and see what it starts. And it'll give us a little thing. There's some stuff here. And it has links. You'll notice it has a link here for case studies. So I could follow here, I could follow within any tutorial, and there's a lot of information to gain in there. And using the tutorial will keep you out of trouble. Okay? Use the tutorial along with your instructor. Now, a lot of tutorials really aren't. Okay? They're kind of like this level, and we're operating at this level. So what we need to do is look through them, see what you get from them what you can. But the tutorials I found to be very helpful. Okay. Notice now I'm back into, this is the basic format for SPSS. And you look down at the bottom here. I don't know, those of you in the back are probably going to have to stand up a bit. But you'll notice that there's two different views here. There's one view that says Data View. See where it's highlighted? Data View.
Does anyone know how to take that off the bottom of the screen?
I'm sorry? Is there a way to do that? Did you get it?
Yeah.
Everybody got it? Okay, so that's the data view, and it looks very much like an Excel table, right? Because what it does, it has rows and columns. Columns going this way, rows going that way. And then it has a thing that's called a variable view. Okay? And the variable view is where you're going to list the characteristics of your data. And I apologize. I just got back from a Mediterranean cruise. It was hard work, but somebody had to do it. And I didn't get a chance to do a handout for you guys. And then Craig called me, be ready at 1 o'clock today. And so I'm here. So I didn't get a handout to you. I will post a handout on the portal for this class. And so you'll have all of this written out as detailed as I can get it. Okay, so we got the variable view and where we're going to do the characteristics of our data, and the data view where we're actually going to enter our data. Okay, so there's two different screens here that do two different things. One of the problems my students often have trouble with is they try to enter data in the variable view. It doesn't work. It won't work. In the data view, you have different columns. The name column is where you're going to name your variable. Let's go back to this name thing. Okay, in this name column, and you can't see the rows here for some reason, notice it's variable 1, they ask for its name. Well, that's where you're going to type an abbreviated name for the variable. Now, there's some key characteristics of naming your variable. 1, you don't want to use any punctuation marks. And 2, you don't want to have any spaces. As soon as I put a variable in, if I put a variable in like this, it says to me, variable name contains an illegal character. Okay? What's the illegal character? You look back there when I typed in my name, what was the illegal character? Can you see it? What's the illegal character there? The space. As soon as I take the space out, ka-chung, it works. See it? Now, notice that the first line here, this first row, doesn't have anything, it has a number in it. It has VAR 00001. If you don't name a variable, your variables will all be named like this. So this will be variable 001. This would be 002. Next one's going to be 003. Veil becomes a little character. What was the illegal character up there? Oh. Thank you. Let's just pass these puppies out. Thanks, Craig.
Sure.
He's your dean of students, right? Notice what he's doing. He's TAing in this class. He's one of the nice deans. Okay, but variables are going to be named just with numbers. Okay, and so give it a name. You've got no spaces, no punctuations. Everybody okay with that? Understand? Okay. It can be very, very frustrating to have this. Let me put it this way. This is usually the first problem that you get into when you start using this program, is you get that statement, variable contains an illegal character. All right? And some of you are not the biggest fans of statistics, so that feedback can be scary. But just remember, look for a space or look for any kind of punctuation. Okay? The next thing that you get to here is kind of data, the type of data. Okay, there's a drop-down menu. See the drop-down? Well, let's talk about what these are. All numeric is the numbers that we're used to using. All right? So the numbers that you get, scores on tests, inventory values, people's responses to Likert items. All of those things are just numerical things. All right? Comma. Now, in the U.S., when we have 3 digits in our own, like sometimes we'll write 100,000 with 100, comma 000, right? That's comma data. In some other countries, instead of using commas, they use dot. Okay? Any of you from a country where they use dot instead of comma? Okay, they use it in some places in Europe. Scientific notation. When you probably were somewhere in undergraduate school or high school or someplace, you took this thing where you talked about powers of 10, and they talked about 1.3 times 10 to the third or whatever that was. That's scientific notation. Okay? Date is just like it says. What's the date? Now, sometimes date is important. For example, if you're doing a longitudinal study, the date would be very important. Okay? Dollar, just as it said. Custom currency, that's usually things like the euro or yen or, whatever the, pounds, whatever would be in there. And then string. String is like nominal data. It's not numerical data. So it's going to consist of two things. It's going to consist of letters and numbers together. All right? So whenever you have words, when your data is in the form of words, it's a string variable. Okay? String variables are variables in the form of words. Okay? Can't calculate with words in this level. Okay, so that's everybody clear about that? So we're going to select a type of a variable type. Then this is the width of your of the file fields in the data view. Notice this is set to 8. Let's say I wanted to set it to 6. If I go over here, you'll notice that the column is a little bit smaller for this one. In other words, you can set up the width of the column. Now, why do you want to change the width of the column sometimes? Okay. When you have a lot of variables. If you have a lot of variables, you want to make the width of the column as small as you can, because then you can see more on the screen. Okay? So for most of the time, you'll see you won't have that many variables to exceed, but the smaller the column, the more you get on the screen. The more you get on the screen, the more you can see what you're doing. Okay? Going back to the variable view, the number of decimals. Well, I'm going to go back here to the data view and just put in, for this one, I'm going to put in the number 2. Now notice it came up with two decimals after a decimal and 2 points after it. See it? I can make that up to, let's say you're doing some physiological experiment where you want to use up to 5 decimals afterwards. Five zeros after the decimal point. Most of the time, the stuff that we use, the kind of data that we analyze, is in the form of integers. Okay? You know what I do with my class, by the way? When the phone goes off, I make them bring a pizza to class for the next class. And I realize I didn't put mine on silent. Because hers went off, see? You want to bring a pizza next time? Alright. Most of the stuff we use is integers, whole numbers. Are whole numbers, right? So what I'm going to do, I'm going to back here and make it whole numbers. 0. Now I could have typed it in. In other words, I can go here and just type in I can't on this one. Now, decimal, then labels. We'll talk about doing labels in a few minutes, and then we'll talk about the values in another minute. Yes, go ahead.
Dr. Brown, I have a question dealing with type. To bring up that dial font, what did you do?
Okay, I just went in here, and I went to that cell. Now, you see the little line next to it?
Yeah.
Click it.
Okay.
It's just a drop down.
Okay.
Everybody see that? Okay. Let's look at this data that I gave you. Let's look at this set of data I gave you. Okay. If you look at these data is plural. I'll try to use that. Sometimes I do, sometimes I don't. It should be these data. If you look at the data, it's got the name of a student, it's got the gender of a student, and it's got a test score for a student. Let's just say it's a classroom test, or quiz test, all right? So I have a bunch of students here. I have, Ali is a male, and his score on the test was 89. Francesca should have been a male, but it turned out to be a female, and score was 95. Okay? See how this is what you typically get when you administer a test, when you administer a survey. How many of you guys are already starting to collect data for your dissertations? couple of you. Okay. We can use your examples. I want you guys who are gathering data, let's make sure we get your questions answered, okay? And I know this is very basic. We're shooting for lowest common denominator here, but if you've got an advanced question, shoot, and I'll try to answer it for you, okay? So, this is how you get your data. In other words, you gave a test, you know their name, you know their gender, you know their test score. Okay? First thing you want to do is you want to code the data. Okay. Now, what is coding all about? All of you have taken something about qualitative research, right? Okay. Well, we're going to do the same thing for qualitative research. Remember, all qualitative data can be analyzed quantitatively. All quantitative data can be analyzed qualitatively. Okay? So we're just going to do a little bit of that right here. So every time, the first thing we're going to do is we look at the gender. See the genders there? Okay. What I've done is I've just coded it. If it's a male, it's a 1. If it's a female, it's a 2. Okay? Very simple coding. So every time it said boy or male, 1, I've replaced it with a 1. Every time it said female, I've replaced it with a 2. Now let's hope I didn't screw up and do that coding wrong. Okay, then another thing you need to do, and this is real important when you do, especially when you're doing a dissertation. You get data from a number of people. You're gathering data from a lot of different people usually, right? It's real easy to mix up your data. So the first thing you want to do is what I do usually is I alphabetize my people. That's sort of to get away from any special thing going on. And then I put numbers. So number 1, 2, whatever number I peep. So I write numbers on each one of my surveys or each one of my instruments. So this is number 1. Then if I have another instrument, let's say I have a survey and a demographic sheet. I want number 1 survey matched with number 1 demographic sheet. Okay? Because if you don't do that, it is so easy to misplace data. And it sounds silly, but I can't tell you how many times I've seen it happen. Yes?
I just want to clarify what you said. So if you were having one person taking multiple surveys, you'd label them all 1?
All of them would be 1 or 3 or 17, yes. Yeah, that's just to keep track of your data so you can keep them, How many of you have ever dropped a pile of papers? I'm a klutz. I drop papers. They don't always fall in order. So if I got them numbered, I can get them right back into order. Right? So this is just number your data like that. I did my dissertation before there were computers. Okay? It's unbelievable. I say it now and people laugh. I taught my first stat class in 1965. Most of you weren't even born. Some of your parents weren't even born. Okay? But at that time, it was so easy to lose data and so easy to get screwed up because everything was done by hand. And it was like, this is just a technique I've learned to use, and I strongly recommend still using it. Okay? So I've got participant number. Now, let me just show you something here. Remember I said I like to alphabetize my people? So let's say I have a person named Abe and a person named Bob. Okay? So those are alphabetical, right? I number this 1 and I'll number this 2. Make sense? Well, all of a sudden, hi, I think you need a handout. Got one? Cool. Okay. All of a sudden, I find somebody whose name is Barb. Well, what am I going to do? Start all over? This is gone, by the way, this goes all the way down to 100 people. Trick. If you're in any kind of situation where you may need to do this, what you do is you make this, instead of 1, you make it 10. And instead of 2, you make it 20. Now what's Barbara? Is 11. See what I've done? So by using the second digit, I've allowed myself to add add people to my data collection and keep it in numerical order. Does that make sense? Yeah, and I find that very helpful. Okay. Hey guys, question. Is there going to be a Moodle port for this?
Moodle port?
These are the bosses.
Yes, we're putting together a statistic Moodle. We already have a basic statistics that goes from pie charts to t-tests. We're just finishing up our second advanced statistics that covers ANOVA and interaction and all that yummy stuff. And then the third one we're going to try to finish it this semester is going to be everything about the dissertation. So it'll have some methodology comp review exams in there, all the handouts and the formal stuff that you guys will need to study up on to get that through. But that should be done by May of this year. So.
Okay, and that's where the handout for this class will be.
Correct.
Yeah, okay. So I will have a detailed handout going through pretty much everything I'm saying here. And please ask questions because I'll know what else has to be included, okay? Hi.
Will you put them on Moodle?
I'm going to put them on Moodle. So when you guys go to Alliant Moodle, they should show up the next time you log in. If you don't, go ahead and email me. I will go ahead and physically, manually log you in one at a time.
And your email is?
It is, everybody ready? R. Gardner, it's Gardner, at Alliant.edu. I am the math learning specialist here on this campus. Yes?
You said something was going to be placed on YouTube?
YouTube. These videos, if it comes out, we're not 100% sure. Sometimes they don't come out because of the smart board and the lighting is all terrible. But if it comes out, what we do is we host them on YouTube. Alliant has a YouTube/edu channel strictly for colleges, and they allow us to put up to 2-hour videos on that, which we already have several up there. But they're all about like the ANOVA, interaction, all that advanced statistics concepts. We have Christina, if you guys, I don't know, but she was one of our ex-tutors, one of the TAs. She goes over them by hand, and now we're making screen capture videos of the SPSS as well. So we have some stuff up there already.
And among the things that are up there, these that you just referenced that are already completed?
Yes, they're already done.
Okay. So we just go to YouTube and type in?
No, go to Moodle.
Okay.
What I'm doing is I'm taking the good ones that we make, put them on the Alliant Moodle site. But there are a lot of good resources on YouTube. Okay? If you can weed out the water skiing squirrels, there are a lot of good resources on there, not just from us, but other schools, Stanford, Harvard. There's a lot of good materials on there when it comes to statistics. So.
Did you add them recently?
Yes.
Last time I logged in, I didn't see anything for the SPSS or anything.
Yeah, I just recently put them on there after the last break. So now we tried to get it so anybody that enrolled in a statistics course, these Moodle courses would automatically appear, but they can't do that. So what you have to do is you have to email me, and then I'll just go ahead and one at a time just put you in there and then email you back saying you're ready to go. So.
I'm sorry, your first name?
Richard.
Richard, can you add me? I think you got my email. Please. If not, I will email you. You got it. Yeah. By the way, I got to tutor a stat class at Harvard this last semester, and all of my tutees got A's, and that's at Harvard, and that's a pretty serious place.
Didn't get much more serious than that.
This is Alliant is the Harvard of the West. Okay.
Amen. I'm out of here.
Bye. Thanks.
Thank you.
Okay. Anyway, okay. I'm a 70-year-old man. Where was I?
We were coding the data.
Coding the data. Thank you. I mean, you haven't had a 70-year-old professor yet, have you?
Yes, Dr. Matriano.
Oh, really? Okay.
She's older than you.
You think so? Nobody's older than me. The dirt is older. I'm older than the dirt around here. Okay, I'm going to need to look on. I don't think we have enough copies, so I'm going to need to look on with you. So we're at the second page here, and we're coded the data. We've numbered the data. Okay? And we have the test score. Now, what I'm going to suggest you do, this will be yours. I'm just using it with you. I'm sharing. What I'm going to suggest you do, how many of you have this PASW at home? 1, 2, 3, 4. How many of you have SPS or Excel at home? Look at the difference in the numbers. Lots of people have Excel at home. Not many people have SPSS at home, or PASW. So what I'm going to do is I'm going to show you how to get your data entry on Excel. So let's open Excel. I have no idea what that screen said, but I'm closing it. Okay, so let's go to Excel. Is it up here? No.
Microsoft Office.
Microsoft Office right there, right there, right there. Yes?
Dr. Brown, I know you said this one, the SPS is 17. Is that what you said?
Yeah.
Okay, I have 14 at home. Is that enough to do a dissertation, or do I have to upgrade?
Let me ask you, what are you going to do in your dissertation?
I'm basically looking at self-imposed isolation, and there's around about 31 variables that I'm using.
And do you want to do, what kind of comparison are you going to do? Like, well, let me answer the question another way.
Okay.
If you are going to do a path analysis, this version 17 makes path analysis quite easy. If you're going to do, and that's the only difference I've seen. If you aren't going to do a path analysis, and how many of you guys are going to do a path analysis? Good. How many of you have ever studied path analysis? Okay. So if you're going to do one of those, you probably are better off getting this one. Or, bless you, or do it at school. Use them here so you don't have to, do it at home. But for everything else, like factorial designs, any kind of compare means, any kind of correlations, factor analysis, you can do on the 14. Yeah. It's remember it added the predictive value. Well, why would you do a path analysis? You do path analysis primarily for prediction. So they're probably simplifying some of their predictive models. So they're using that's why path analysis, by the way, I was amazed at how simple path analysis is on this 17. It's just, it does it for you. All the hard parts of path analysis are done automatically. Anyway, we got Excel open. Again, we can't see the lines. But here's what I want to suggest to you, because most of you do have Excel at home. You take that data matrix that you made, and you put it on Excel. So let's see if we could do this. What we'll do is we'll put in, the first variable is going to be name. So this column will be name, right? This column will be number, participant number. See it there? This column will be gender. And this column will be test score. Okay? Notice I didn't do them all the way out. And so I can put all my names in here. And I'll go like Ali. Anybody particularly good at doing this? Who wants to volunteer so I don't have to do it myself? Thank you. See, none of you guys are in my classes. I can usually blackmail my students. You know what? Yeah, or let me see if what I can do. I asked my wife to email it to me, but she didn't do it. At least when I looked at my email. How many of you people are wives? How many of you people do what your husband asks you to do? Never. Yeah.
I asked. That's why I stay married.
Yeah. But anyway, that's the way it goes. So if you don't mind, and we're just going to put these numbers in. Thank you. What's your name?
Dion.
Dion. Thank you. Anyways, as she puts the numbers in, they're already coded, and she's just going to do that. Put all those numbers in, and it should flow pretty easily. Now that she's doing it instead of me. Okay, and then you want to go down to the.
Take it back.
Yeah. Click on this though, right there. Yeah. Okay. Any questions so far? Is this level too basic? Yes. No. Too basic. Okay. Is this level about right for some of you? One of you is about right. Is this level boring for all of you? Well, give me some feedback, guys, because
I think it's good to go over the basics.
Okay, just review them. Yeah. Okay. And you guys can check Dion while she's doing this. Any other questions? Go ahead.
So we're putting it in Excel. Then why not just do dissertation in Excel?
Because Excel will do pretty much all your dissertation, but it's much, much harder. In other words, I can do a t-test, or we can do a t-test on Excel, but it takes about 5 steps. Okay? To do a t-test in PASW, are you right-handed?
Left-handed.
Left-handed? Okay. All of you left-handed people, get with me, and all you right-handed people, get with me, okay? If you're left-handed, you hold the mouse like this, and you go click. If you're right-handed, you hold the mouse like this, and you go click. Everybody try that. Try it. That's how you do your statistics on PASW. With Excel, we can do all of those operations, but it's going to take a lot of cutting and pasting and saving and transforming and yada, yada, yada. Whereas this PASW is a dedicated program that does your statistics real quick. It's just so much more efficient and effective. Plus, Excel tables are not that easy to read. You'll see that the tables that come out of here are pretty easy to just paste into Word. Okay? But that's a very good question. And there's nothing saying to stop it. Honest to God, I did my dissertation on a Marchand adding machine. And I did a complex factor analysis. I used to be 6'4", have a full head of hair. But it can be done. Okie dokie. Thank you, Dion. Okay. So we got our data entered. All right. Any of you OCD? So all I do over here is, because of my OCD, is I'll just take that and center it. And then I'll take these and center them. Doesn't really matter. But it satisfies my OCD. Okay? I didn't change anything other than how it sees up there. Okay, so we got our data entered there. All right. Now, what we're going to do here is let's open the PASW. We're going to go back in there. And we're going to cancel this because we don't have anything saved. And we're in the variable view. So let's look at our SPSS, our Excel. And what's our first variable? Name. Okay. Name. Okay. What kind of variable is name? Okay, it's string. Why is it string? Because it's got letters and numbers, and you can't do calculation with letters. Not even in Roman numeral. Okay? So we're going to say it's numeric, but we're going to change it to string. The default is numeric, so we change it to string. Okay? 8, no decimals, no label, no anything. What's the second variable? Participant number. So why don't we just do that? What if I do this? What will happen? What's the error going to be? Take the space out. Or I could just put number in. Okay, I'm just abbreviating it. Okay? Numeric, it's 8 wide. Do I need any decimals there? No. They're all whole numbers, right? 0. Got it? Okay, nothing there. What's the next variable? We'll also call it numeric. Remember we changed it to 1s and 2s, right? Okay. Let's leave it at 8. Don't have to change that. If we had a lot of data, we would. Any decimals? No. Now, what we did here is we did the coding. Remember the coding? They were male, female, right? And now they're 1 and 2. Well, we have to tell the computer or this program what those numbers are. So what we do is, see where it says label? I'm going to call this label gender. That's what it is. I'm going to hit tab and go over there to this next one where it says value. Okay? I'm going to drop down the value menu. See the drop down? Saw how I got there? Okay, let's do it again. See, it's got this little line for drop down. Click the line and I get this drop down. The value, well, the values I used were 1 and 2, right? So I'm going to put a 1 here. Tab. And what did 1 stand for? Male. Right? Now, real important here, real important, is remember to hit the add. A lot of people forget to hit the add, and they wonder why it doesn't work. Okay? Now, I'm going to do another value. 2. 2 is what? Okay. Now we're done, right?
No, add.
Add. If I did that, just gives me this warning. And if I ignored it, I got a problem. So I'm going to have to add it. Okay? Now, there's a lot of things you can do with this labeling. A lot of times you have skewed data that you don't want to transform. And you want to take ungrouped data and make it grouped data and stuff like that. With this little thing here, with this place, it's possible. And if we do an advanced course, I'll show you how to do some of that stuff. How to do the transformations and how to combine categories and how to make things a little different. But right now, this is simple enough for us. So we're going to just say OK. Now, let's say I spelled male wrong. I can check the spelling here. Oh, no spelling errors found. All right? Yes?
So let's say you had a third category for this one, and let's say that it was a building that they were in or something.
Okay, let's put in building. Okay? Just add it.
Oh, okay, so it will just keep making a numerical addition.
Right.
Okay, so 1, 2, 3, 4, 5, 6.
Exactly. Now, this is a very, very important screen, particularly if you're going to transform your data right from PASW to your dissertation. In other words, you're going to use these tables.
Yeah.
Because whatever you put in these labels, that's what's going to be on your printout. Got it? So that's why the spell checker's there. Because people do make spelling errors. And it's a matter of just checking the spelling. Okay? Well, I'm going to take building out right now. So I just remove it. See? Okay. All right. What's the next variable? Score here, but again it's numeric. 8. Any decimals?
No.
Okay. And that's it. So I've just set up my data set. Does any have any questions about that? For a lot of people, it's kind of a confusing step. So let's go back and do me a favor. Why don't you just explain what I just did to somebody next to you? See if you can explain it well. How you labeled your data. How you use labels. Good. Ignore me, guys. Let's wait to get everybody on board here.
Oh, okay, because she can't answer a question I have, and she's supposed to be explaining it to me.
Okay.
And I can't answer it.
Well, therefore, I hope I can answer it. What's the question?
The width that you set up, the 8, is that just for that column, or is it all the columns?
It's just for that column.
Okay.
You set up each column individually.
Okay.
Because I noticed when I was typing in Francesca and Geraldine that the width was not wide enough to include the entire name. So it is possible to change that.
Exactly.
Okay.
Yeah.
Okay. But in this case, it's just.
And so I would need to know how, because I know how to change the width column.
Okay.
But how do you change the name column?
The name. On this one. This one here, the values.
No, the name.
Oh, the name. Okay, everybody got that? A couple questions came up. One of the questions had to do with, what about names that are too long? Okay? Some people have very long names. Okay? So what we want to do is, how are we going to put that name bigger? Well, let's say that there are some names that are 16 letters long. Okay? All we do... And you'll notice, now name will take 16 letters. Now I can put 16 letters in there. Okay? Got it? Okay. Anything else? Any other questions come out? Did you thank your explainer? They do a good job? I'm sorry?
Wasn't that scientific notation? Was it like multiple?
Okay. A question came up about scientific notation. What scientific notation is, everybody here somewhere along the line took a course in chemistry, let's assume, okay? There's a number called Avogadro's number. Okay? The Avogadro's number, most people call it avocado's number in high school. That number is basically 62 with 23 zeros after it. Okay? That number is 620000000. Somebody count for me. And more probably. Got it? Okay, that's a huge number. You don't want to type that many zeros. If you're me, you'd probably put 1 in the wrong place or whatever. Okay? So what scientific notation does is it takes that number and it changes it into 6.2 times a power of 10. And so it uses the power of 10 to the 23rd power. And that's the number of zeros. So all scientific notation does is simplify your numbers. Okay? And you use it specifically for very, very large and very, very small numbers. Okay? Very, very large and very, very small numbers you'll use scientific notation. So if you had something that was 0.00000008, you'd probably put 8 times 10 to the minus 6 or 7. Okay? And it's just a thing that you use. Now, most of us in the social sciences don't do that. You know, the kind of variables we use because, I mean, first of all, there's a big argument, are we scientists? You know, well, I think we are scientists, but not because of what we study, but because of the methods we use. So the first argument is, are we scientists? Well, I think our method is scientific. I think we do things accurately. We're careful. We try to replicate. We use the science. What did I do now? Did I do something wrong? Yes. Go back. Of course, those guys aren't here now. Ta-da! Okay. Anyways, scientific notation is just for those numbers that have a degree of precision that we don't have. You know, we can't talk about an IQ of 101.364. It's an IQ of 101. Right? Okay. Any other questions? Not? All right. So I've got my data here. All right. I'm just going to go back to 8 on this one. And I go back to my Excel. See my Excel? I'm back to my... What I'm going to do is just and only just highlight my data. In other words, I didn't highlight the first row. I just highlighted the data. I'm going to copy it. All I did is Control C. You could also do it up here, wherever it is, to copy it. I just copied it. Okay, so now it's on the clipboard. I go back to my program here. I then go to the data view. I'm in this cell right now, and I'm just going to paste it. I use Control V to paste. And there it is. Okay. Why do I do that? Why do I tell my students to do that?
I would imagine because by entering it a second time, there's a potential for making errors.
There's a potential for making errors. They've got to check it. I also do it because it's usually, for most of my students, they're more familiar with Excel than they are with this program. They only use this program very, very rarely, where they'll use Excel more often. So I like to have it on Excel so they can look at it, they can print it out, they can play with it, they can change things, and they look at it in Excel and they're comfortable. Sometimes they go to this program and they get a little tremor, you know, and not all of them, but some of them do. So what we want to do is minimize the tremors here. So all we've done is cut and paste. Yeah, go ahead.
Well, could you go to open an existing data file and open the file?
No, because it's saved in a different. Excel is EXL, I think, is the suffix. It goes .EXL, and this is .SAS or SAV. So it's a different file format. Now I don't know. It may be possible to save Excel as SAV. I don't know. It's a good question. I don't know. If it is, what you could do, if you could save it as SAV, then you could probably analyze it. Does that make any sense? Did that answer your question? Reasonable answer? Does that make sense?
Yeah.
Yeah. So it's like, you can try it. But I like to do it this way. This is how I teach my students how to do it. Yeah. It's force a habit. Yeah. Okay? Any other questions? Nada? Nothing? How are we doing for time? 4? About an hour? Perfect. Okay. Now, we've got our data in here, right? What's the next thing you're going to do? What's the next thing you would do on anything?
Run the...
Save. S-A-V-E. Save. Save your data. When I was a graduate student, we used to put our data in the refrigerator. Honest to God, we put it in the refrigerator in case there was a fire in the house. Save your data. Got it? Yeah, it's funny. Hey, I'm old. What can I tell you? I mean, this is how you had to do things. Save, save, save. Got it? How many of you would have saved your Excel? Well, now that you think about it, might you want to save it? Yeah. You got it. Yeah, you can't save too much. All right? Okie doke. Now, I have no idea what this is, so let's just get rid of it. Okay. We're up here. We have a lot of menus. File and edit are pretty much the same in all the programs. And there's a lot of things you can do up here. For example, let's say you want to do correlation and you have one variable is skewed. Okay? Or you want to do a t-test and you don't have homoscedasticity. The variances aren't equal. And you have a lot of things where there's a lot of assumptions that underlie the statistical procedures you can do. Okay? Well, there are ways, legitimate, not long sleeve, but short sleeve, way of transforming data so that you can do very fancy analyses with some data that's less than perfect. Okay. The assumption is a very important assumption, that in the population, the variable, let's say, is normally distributed. Now let's do IQ. Okay, IQ pretty much we can assume in the population normally distributed, right? But let's do it in this room. Whoa! All of a sudden we have a very highly skewed, very narrow distribution of IQ, right? Probably with a very high mean, probably a mean 120, 130, who knows, right? You guys are doctoral students. Does that mean intelligent? No. Okay. That's honest lady. Well, if you're an MFT student in my program, yes. We pump them up. Even if they aren't, they think they are. All right. Anyway, so we don't have a normal distribution of IQ, but we know that IQ is normally distributed in the population, or we believe it to be. So we can transform it to make it look like a normal distribution. And all of a sudden we can do a whole bunch of other statistical procedures. Okay. Using our data here, and that's in here, we'll talk about transformations and data and changing data, do all kind of fancy stuff in here. But let's just go to this analyze thing. Drop it down. Reports. This is really nothing. This is just your your Excel file is the best report you got. Okay, you're not going to find anything new in there. Descriptive statistics. Well, I go there, I can have frequency, descriptives, explore, crosstabs, ratio, PP plots, Q plots, all kind of stuff in there. And by the way, if you have to do chi-square, the best way to do chi-square in PASW is using crosstabs. So chi-square is done best on the easiest way to do it is using crosstabs in PASW. Okay? Because what it does, it's going to give you rows and columns, which is what you need for chi-square. Then you go over here, and it lets you find chi-square, correlations, and all of these other things that are related to chi-square. You can even find, by the way, you can even use this. This eta is what you use for curvilinear correlation. So if you wanted to do curve fitting, you do curvilinear correlation with that eta. Gives you a lot of stuff. Okay? It gives you changes. So this crosstabs is a very handy thing if you're going to be using, in particular, if you're using a nominal variable and some other measures. It's very handy. I think it even gives you odds ratio. No, I don't see odds ratio there. But it's not hard to convert that to an odds ratio. Anyways, we got a lot of descriptive. Then we'll do this compare means. We'll look at all the different ways you compare means. One sample t-test, independent sample t-test, paired sample t-test, one-way ANOVA. You know, all of these things here. So you were asking, why can't we do them all on Excel. This is why. Look at all the extra stuff we can do here. So, anyway, let's take and find our descriptive statistics. All right? Let's go to description, and let's use frequencies. Okay, so I'm going here. I went down to descriptive. I went over and selected frequencies. Okie doke. Now, do I want to find descriptive statistics for the participation, for the participant number? Is there any reason I need that? No, I don't need that. I just need gender and score. Now notice what I did here. How did I get it over there? What I do is I highlight it, and I can highlight them both at the same time, and hit this little thing in the middle. Click, and they're over in this side. In other words, this is just a list of the things that are on the data view. Okay? These are the things in this box here that are going to be analyzed. So I shift them over here. Now up there at the top I have see where it says statistics? See that little box? Click it. And I can find all of these things. I can divide it into quartiles, percentiles. I can find all kinds of measures of central tendency. Why don't we find the mean, and why don't we find the median? Now, let me ask you something. What kind of data is gender? What level of measurement is gender? Categorical, that's right. And is it nominal, ordinal, interval, or ratio? No. It's just nominal data. Right? It's only nominal data. Now, it doesn't have any other characteristics other than it just is a name. The number it's just a substitute for a name. In other words, the word male is a 1. The word female is a 2. Does it make any sense to talk about a mean gender? Makes no sense at all, does it? But guess what? The computer will find a mean gender. Got it? So what happens here, and this is the problem with this thing, this program will do anything under the sun. It will make all of you the most powerful statistician in the world. Unfortunately, some of the data will be worthless. Okay? Because this is where you have to know the stats. You have to know that the mean gender really means nothing. All right? Yeah, I mean, you have to know that. You have to know that only certain things work with certain data. Only the level of measurement, that nominal, ordinal, I combine interval ratio, really determines the kind of statistics you can do. You know, you can't do a t-test with nominal data. You shouldn't do a t-test with ordinal data. It just doesn't work. Have you heard the word robustness? Okay, this is talking about this is where you're challenging being robust. And so it doesn't work. So let's find a mean. What else should we find? How about a standard deviation? Is that okay?
Yeah.
No?
Yeah.
Well, you want to find anything else? Well, just for the sake, let's just do this. Let's just do these. So, okay. Where could we find a histogram? We'd have to go to charts. Okay. Now, the data I have here, the model I made for you, your example, is not going to be good for a histogram. Because, let me show you what's going to happen. Well, we'll do it. We'll do it a bar chart or a histogram. It doesn't matter. All the difference between a bar chart and a histogram is where the categories start. Remember the thing of upper limit, lower limit? Well, okay. if you want to do probably a bar chart rather than a histogram. It's really the same thing. It just has different limits on it. We're going to do it on frequencies. And now, to do the calculation, remember I said how many of you are right-handed? Okay, what you're going to do is the right part of the mouse, unless you have a Mac. If you have a Mac, you just push anywhere. You just go like, OK. Let's find OK. Good, I didn't do it. And it's done. Got it? Okay. What this is up here, these things that come out up here, this is the code telling you what this computer did. It said we went to the frequency column and we analyzed two variables. What were they? Gender and score. Okay. It said we found the standard deviation, the mean, and the median. It said it made a bar chart of frequency, and now it went to do the analysis. Now, any of you know about any kind of programming? All these are just general steps that it tells the computer the order of what it's doing. So you really don't need to know it because you're just going to use the output. I mean, if you're interested in how it did certain things, maybe it's important. Frequencies. Okay, this is the frequency of gender. And it says the mean gender is 1.5. Well, what do you think that does tell you? What was the highest gender possible? 2. What's the lowest gender? It's right in the middle. So 5 men, 5 women. Correctamente? Okay. So this. Sure.
On N, the number of people who are participating in ballot, it looks like ballot missing.
No. Yeah, that's a good point. Okay. When you start really doing research and gathering data, not everybody gives you answers for every item. There's a lot of missing data. Okay. So there's some choices of what to do with the missing data. Some people just exclude it. Throw it out. Hey, they didn't answer it. Tough. Goodbye. Another approach is to find the mean for all the rest of the data and give the person that mean value. Another approach is to do a regression analysis based on the variables that you do have and predict a value for the missing value. Okay. Which one are you going to use? If you're in a hurry,
Throw it out.
Throw it out. If it's your life's work and it makes all the difference in the world, regression. Now, where's your dissertation? Somewhere between there and there. All right? So we got the mean. Now, what's the mean for score? I tell you what, don't tell me. Tell somebody next to you. I'm next to you, so you told me. Thank you. Okay. The mean is 92.60, and it says the median is 92.50. Well, what's the difference between a mean and a median? What's the mean tell you? The average, right? I realize I just got out of this camera view. Okay. It tells you the arithmetic average. What's the median tell you? The middle score, half above, half below, right? So, which is most valuable here? Okay, as a general rule, if you're going to do more stats with this, use the mean. Particularly in this case where they're so similar. Okay? So always we'll use the mean. What about the standard deviation? Can you see the standard deviation for score? 4.1. Now, do you think you should use 4.115? Why not? It's applying a degree of precision that you don't have. Right? Now, we like to say gender are two classes. Guess what? That's not exactly true. Okay? That's not completely true. So, The best we can do here is we would probably go to 4.1 and round it. We'd round it to 4.1. All right? What if it were 4.15? What would we round it to? 4.2. We're going to round to the even. That's just a convention. There's no reason to do it other than it's conventional, other than people tell us to. It's being consistent, rounding to 4.2. Okay? 5 and 5. 5 men, 5 women. I probably did screw up on that first page. Okay? 50%, 50%. Valid, invalid. Okay, again, that's valid is only based on those that are usable, only those that answered the question, okay? And then cumulative, you know what you use cumulative for? What's the common thing of using cumulative for? Is to find the median. Okay? Okay, the score. Hey, can you fill out one of the things so I can improve this? Do you mind?
Oh, sure.
Would you do that? And just tell me what to do to make it better.
Okay, is it alright if I bring it back tomorrow?
Yeah, whoever the guy is.
Okay.
What's his name?
Richard.
Richard.
Excuse me, Dr. Brown, you said the cumulative percentage is...
Thank you. Bye-bye. There's Richard right there. She's going to give you one. Excuse me.
Is to find the median, you said? The cumulative percentage.
The cumulative frequency is used to find the median. Okay? We use that to find the median. Okay, so now we have the scores. Well, what do we notice about these scores when you look at the frequency? Something funny's happening here. There's a 1 and just one with a 2. So what's the plot going to look like? That's for gender. That's for score. So here the chart doesn't show us that much. Okay? If we had some real data, if I used some real data, it would do. So if one of you had your dissertation data, we could put it in here and see what it actually looked like. Okay? Got it? Any questions about finding descriptive statistics? Go to frequency, select what you want, use your index finger on your preferred hand, and you got it done. All right? Everybody clear? Clear? All right. Analyze. Let's do the correlation. And we're going to do, how many variables correlate? Just 2, right? Which is bivariate correlation. And let's just look for a correlation between gender and score. Okay? Now, any of you know that's in this case, it's going to be a point by serial correlation coefficient? Yes? No? Never heard of it? Maybe? Okay. What we're correlating here, we're going to use the Pearson product moment formula. We're going to use the Pearson formula to find a correlation between a true dichotomy, gender, and a score. Correlation between a true dichotomy and a score, that coefficient is called a point by serial. And that's, just look it up. That's what it is. There's different correlation coefficients, and that's the one we're finding here. Okay, it says Pearson. Okay. These other two are really primarily for ordinal data. Now, we're going to test significance. Okay, what's a significant test for a correlation coefficient? The null hypothesis. Can you think of what the null hypothesis for correlation would be? It would be something like, in the population, the correlation between these two variables is 0. There's no correlation. Okay? Said another way, or we can just do it symbolically. We could just point by serial equals 0. There's no correlation. So that's the null hypothesis. What would the research hypothesis be? It'd be different from 0. Yeah, it would be like this. Let's just do it here. We could either do HO. I'm just going to use R equals 0. H1 R doesn't equal 0. Right? Make sense? So if there is a significant correlation, if there is a correlation and it's significant, that's the hypothesis we're testing to see if there's a significant correlation between the two variables. Question: what if perchance you think there's a significant positive correlation? You think there's a significant positive correlation. In other words, your H1 is R greater than 0. That's a significant positive correlation. What would the null hypothesis then be?
It means that there is a positive relation between two variables.
Mm-hmm.
And the other way, if one is high, the other one is high as well.
Mm-hmm. Yeah, exactly right. What do you think you would use as a null hypothesis here? Well, the null hypothesis has got to be exactly the opposite of the research hypothesis, right? Exactly the opposite. So HO is R less than or equal to 0. Does that make sense? Yes? Yes. Thank you for responding. Keep me from going too autistic.
I have a question.
Sure, thank you.
If by mistake we enter something and then we want to go back and correct it and run it again, is there any way to erase?
Okay. There's an excellent question.
There was like multiple things and...
Yeah, the question is, what do you do if you want to change something? Okay. And the answer to that is it depends on how big a change you want to make. Again, I'm OCD. So what I do is I make 2 copies of everything. I save 2 copies of the data. Okay, I just label one A and one B, or one with a date and another with a different date. Okay. Then I make the changes on one of them and don't make changes on the other. Okay? Now, in terms of results, I find it cumbersome to save results in this program. So what I'll do, and I'll show you how to do that, I copy the results and paste it into Word, and then save a Word file with the results. Does that make sense? Yeah. Because it's easier for me to work with Word than this. Okay. Now notice it has, down at the bottom here, right here, it has test of significance. It can be 2-tailed or it can be 1-tailed. How many want 1-tail? How many want 2-tail? How many 2-tail? How many 1? 2 it is. Okay. Now, what do I do here? Yeah. By the way, the options up here just tell you what to do with missing values. Okay. So it's like, it just tells you 2 options to do with the missing values. Okay. And there's our correlation coefficient. So, in this case, the correlation is 0.62. See it? 615 we ran. And it says the significance is 0.059. See where it says sig? And it says the n is 10. Now, you have to read that significance like this. You read the significance as something like this. It says the probability of the null hypothesis being true. Notice I didn't use the word tenable. The probability of the probability of the research hypothesis being true. Probability of rejecting the null. The probability is 0.059. Now what do we typically need to have statistical significance here? It has to be smaller than 0.05. 0.01 or 0.05. Those are conventional values. Is this smaller than 0.05? Nope. Nope. So what do we have to do? We accept the null hypothesis. Got it? Now, just for the heck of it, let's go back and do this with a one-tail. Going to do exactly the same thing, bivariate correlation, and now I'm going to do it with a one-tail test. In other words, I'm willing to bet that there's a direction of the correlation. Okay? And what happened? It became statistically significant. Okay. So what does it say about doing dissertation that's finding significance? It's a lot harder. I have a number of students who, not a number, but I have several students who don't get their hypotheses. It's a lot harder to explain not getting significance than it is explaining getting significance. Okay? So, the lesson or the moral of this story is, whenever possible, make the strongest hypothesis possible. E.g., try to make one-tailed hypotheses. If you can predict the direction, you increase your likelihood of finding statistical significance.
Could you say that again?
Sure. If you can predict the direction of a change or of a statistic, of something that's happening statistical, that becomes a one-tailed hypothesis. One-tailed hypotheses are much more powerful than two-tailed hypotheses. They're 50% more powerful, actually. Do you know why? Let's just digress a bit. How are we doing for time? Okay. Okay. This is the confidence interval. This is the area where you're going to accept the null hypothesis. Okay? This is where you consider the HO true, or tenable. Proper word is tenable. You consider it tenable if it's in there. Alright? When you reject the null, in this case we're looking at 0.05. That wasn't very symmetrical the way I drew it, but get the idea. 0.05 is 0.025 here, and 0.025 here. Got it? If you look at it, that's kind of far away from this mean. Okay? With a one-tail, if you look at the one-tail has the whole 0.05 over here. So in effect what it's done is it's moved this another closer to the mean. That makes sense? Mm-hmm. And so what we're doing is we're increasing the likelihood of rejecting our null hypothesis, which is what you want to do in most research. But you're using Fisher's logic.
Well, if that's true, then why would another researcher?
Okay. First of all, you use the two-tail because sometimes it's politically correct. Okay? Realistically, it is. Sometimes you just have no basis to make a prediction. You have zero reason to make a prediction. I have no idea. Are people in Greece friendlier than people in Egypt? Huh? I was just in Greece and I was just in Egypt. Who was friendlier? I have no reason to make any prediction. I just want to find out. Two-tail. On the other hand, if I want to say something about students in graduate school have better quantitative abilities than students who aren't in graduate school, I have reason to make a prediction. So it depends. It doesn't really. It's not a statistical question as much as as a research logic question.
Okay, so politically correct. How would you use the two?
Okay, this is real interesting. My son teaches at a historically black university in Mississippi, and there's a lot of stuff that happens down there that's a little crazy. Okay, a lot of good stuff, some not so good stuff. And it's sanctioned by the government. If the governor says that I think that we're going to have I'm willing to support inferior education at the historically black state universities, and I'm going to have better education at the non-black universities. Do you think that's good? Do you think that's a violation of civil rights, etc., etc., etc.? Would that be unconstitutional? Okay, so the governor can't say that. He can collect data to maybe try to show that, but he can't say that. It's just not politically correct sometimes to say that there are differences and then set it up to make that difference. As soon as you make the prediction of a difference in a direction, you're saying that I have a bias in that direction. Okay? And you don't want that. It's not a good idea to be showing your bias, and that's what I mean by politically correct.
Okay, because I'm thinking of the bell jar. It's the bell curve.
Bell curve.
Not the bell jar.
I like a bell jar too.
The bell curve, from what I can understand, it used directional. It was a prediction.
Okay, you can do either one. And what it goes back to is it depends on the statistical test you're using. For example, chi-square is always one tail. You can't make a two-tail chi-square. Okay? But you can make a one-tail t-test. Can't make a one-tail f-test for ANOVA. No way. Just doesn't work. Has to do with the shape of that sampling distribution. It's kind of like beyond the scope of what we're trying to cover today. But sometimes you can't do it. But my son gets paid a little bit less because he teaches at a historically black university than if he were teaching at another university in the same state. Do you think he likes that? Oh, he just loves it. He doesn't care about money. Right.
And Dr. Brown, the other thing that would determine whether you're using a one or two tail would be based on the literature that you find in your research.
Exactly. That's really what you base it on. You base it on, in this case, when we're doing quantitative research, you base it on deductive logic that leads you to that point, to lead you to say that. And the deductive logic leads you directly. And then what do you deduce from the literature? Okay?
So for chi-square, we use one tail, but for t-square?
No. Okay, a little bit different than we want to talk about in this class, but I brought it up so I'll answer it. Chi-square, the null hypothesis, is there's no relationship between the two variables. And you reject null hypothesis if there is a relationship. Okay? And it's not like there's a significant... You don't talk about significant difference with chi-square. It's more like a correlation. Null hypothesis. Okay. Everybody okay? Moving right along. Let's do now a t-test. Now I can leave this here. In other words, I can leave everything on here, but let's say I think it's getting cluttered. I can highlight it, and then all I do here is push the delete button, and it's gone. All right? And I said I was going to save it and put it in Word before I did that. Didn't I? Thank you for reminding me. It's your fault. It's certainly not mine.
So you can't undo it once you do it?
No.
Oh, please. You have to be able to undo. Yeah. You do edit undo?
Let's try Control Z.
Yeah. Seriously. That's a scary thought.
And you can also click on parts that you don't want. You don't have to delete everything.
Yeah, and I get a little impatient. So, okay, so what I did, notice what I did is I just came over here. See that table? I selected it. Control save, which is Control C. I'm going to open Word. I always space down a couple spaces. The reason for that is so I can put a title above it. Okay, space down a couple, paste it. And there it is. How's that work? Is statistics easy?
No.
It's enjoyable.
It's a POC. It's enjoyable. Piece of cake.
No.
Did we do piece of cake today?
Yeah.
All right. Now let's go back here. Let's do a t-test where we're going to go back to this guy. Analyze. What do you think a t-test is for?
To compare.
Compare means. Okay. Now we're going to compare males and females. Question. What kind of t-test is that? Are they related samples or are they independent samples? Now, in my class, what they usually do is they start looking down and start writing notes carefully at this point. They're independent samples. Yeah, they're independent samples because the boys and girls are different. There's a sample of boys and a sample of girls. Okay? Sample of boys, sample of girls. So we're going to do an independent sample t-test. Ka-chung. Now, you'll notice it has test variables and grouping variables. Okay. Let me put it to you this way. Let's relabel these. Where it says grouping variables, you could just as easily write independent variable. I'm just going to put IV. Independent variable. The grouping variable is the independent variable. All right? If I want to look at, is there a gender difference in scores in that test? Okay? I'm making a hypothesis. There's no significant difference between test scores for males and females. What's the independent variable and what's the dependent variable in that hypothesis?
Is score independent of gender?
Independent is gender, and score is the dependent. Got it? So up here, where it says test variables, just think of this as the dependent variable, and just think of this as the independent variable. Cool? All right. So the independent variable here is
Score.
Independent variable is gender. Gender. So I'm going to click it down here, and I got to select it first, send it in here, and my dependent variable will be put it in there. Got it? So now I'm asking the question, is the score a function of gender? But look at the little thing on gender. When you look at it, it's got two little question marks. See the two little question marks? Those two little question marks ask us, what are the different categories you're going to be analyzing? So I go over here, and it says define groups. See where it said define groups? Click on it. And I'm going to have group 1, males. Well, I'm just going to put a 1 in, because remember that was males. 2, female. Continue. And click OK. Boom. Now, look what came out. It says there's 5 males and 5 females. The mean for the males was 90.2. The mean for the females was 95.0. So they are different, but we don't know if it's significantly different or not. If we make it politically correct, no significant difference, e.g. 2 tails, we'll see what happens. Okay, the mean, these are the same values we got earlier. Standard deviation, and the standard error of the mean. Now, all the standard error of the mean is, it's kind of what this whole idea of inference is based on. It's the idea that You take an infinite number of means from these samples, and this would be the standard deviation of that infinite number of means. It's we don't want to talk about it here. It's not a hard concept, but it would take us about 20 minutes to digress to it, so let's don't. Okay. The first thing it does is this Levine's test for equality of variance. Okay. One of the assumptions, remember earlier on we said there were assumptions underlying all of these tests. All right. One of the assumptions that underlies the t-test is what's called homoscedasticity. And all homoscedasticity means the variance of the two samples or the variance of the two populations are equal. Okay. For those of you who've talked about the f-test is that's exactly what it is. It's a comparison of two variances. It's a variance ratio. It's a ratio of one variance to another variance. And you set it up. So we got an f of 0.037. And is that significant? Is that statistically significant? Don't tell me, but tell somebody. Take a risk. No. Why not? Because it's greater than 0.05. It's greater than 0.05. I'm looking at this number here. That number. That number is greater than 0.05. Therefore, it's not significant. Therefore, backwards logic, there's no significant difference in the variance. Okay? The two variances are not significantly different. Okay? Did you follow that? I was a little quick on that one. And that is, you want this to be not significant. You want them to be no significant differences between the two variances. Because then you can proceed with this t-test. Let's see if I can get it up higher on the screen for you. Well, I don't know how, I'm sorry. Okay. Now the next thing it did is it calculated t. And the value of t was minus 2.05. Okay. Now what does that mean? It's just the value of t. It tells you whether or not you're in the confidence interval or the rejection region. All right? And the degrees of freedom. Whenever you do a t-test, you have to do a degrees of freedom. In this case, the degrees of freedom is the number of people minus 2, which is 8. And the significant is 0.059. Okay? And then it tells me the standard error of the difference and all this other stuff, the lower and the upper and all this other stuff. It says the difference is... Now, if I wanted to make this one tail instead of two tail, very easily to do that. Can any of you think of how you might want to go about doing that? All you do is divide the significance by 2. Just like with correlation. Just take this 0.059 and divide it by 2. Okay? And when you divide it by 2, you have the the one-tail significance. So, two-tail, don't reject the null hypothesis. One-tail, reject the null hypothesis. Two-tail hypothesis. Let's think about what the two-tail hypothesis might be. And this you plan before you start doing this analysis, by the way. Hopefully. I don't think everybody does. Yes, I will admit it. Sometimes I haven't. I got over 100 publications, so lots of, little tiny things I've done like that. Anyway, the issue is what's a two-tail hypothesis for this? There's no significant difference between men and women on the test scores. Okay? That's the two-tail research hypothesis. What's a two-tail? A one-tail research hypothesis. there is a significant difference, or let's put it this way, women score higher than males on this test. Women score significantly higher than males on this test. And I would reject my no. See it? All right. Now, let's say your Levine's test gave a significant F. In other words, this value in here, that value in here was small, 0.001. Okay? Well, does that mean you can't do the t-test? Throw out the baby with the bathwater? No. You'll notice there's two lines here. One of them says equal variance is assumed. The other one says equal variance is not assumed. Got it? So if you don't have the equal variances, you use this bottom line here, the bottom line, and you report that value of t with this value of degrees of freedom. All it's done is it modified the degrees of freedom. So remember I said degrees of freedom for this t-test was n minus 2? Well, it's n minus 2 then with some fraction playing around, because to control for the unequal variance. Got it? Okay, let's stop here. Now, class okay? I want some feedback. This is the first time I've done this. And I literally prepared 20 minutes. Did it look like 20 minutes? I'm sorry?
It was very valuable for me. I
Good.
feel like it could have been more helpful if we were in the daily hall and we all did this on a computer.
I think it should be on a computer. I would agree with that 100%. We all were doing it together. Anything else?
There is a class in M2 building, and they have SPSS installed on all the computers. Because I did one class there with Dr. Ansel. So
we could do it there if we're going to do it again. Yeah, see, you guys are the group that even says that we're going to do it again. And you know, yeah, I mean, it's your vote decides whether we go or not go. So, yeah, go ahead.
I think it's a great refresher for the basics.
Okay. Anybody find it totally inappropriate? Anybody find it very valuable, highly valuable? Okay, yeah.
I think it's really good because when you're actually in a statistics class and you're thinking about doing your dissertation, there's a lot of questions you want to ask, but you don't want to derail the class by asking these questions. So this is a great opportunity to take this information and then apply it to what you're doing.
Good. Well, I'm happy to do it. I appreciate you guys. Thank you for asking questions. Thank you for coming. I hope it was a good...